Hello students, in our last module we've learned that objects can be classified into three categories. And what were those three categories? Yes, we have transparent objects, translucent objects, and finally opaque objects. So where transparent substances, they allow the light rays to pass through them completely. And what about translucent substances? They allow only a fraction of light to pass through them. And then we had the opaque objects, which do not allow the light to pass through them at all. And now the question arises that how does light travel? Does it travel in a straight line, or in a zigzag manner, or in a curved path? Well, to understand this concept, let's have three cardboards, cardboard A, cardboard B and cardboard C, and they are of equal sizes with fine holes punched in the center of each card at the same height. And then we also have a piece of thick paper sheet which will be used as a screen. And finally we have the source of light, which is this laser torch. Now each of these cards, it is set into the modeling clay and aligned in such a way that they stand in a vertical position at some distance from each other. And you can see here that all these holes which we had punched in these cards, they are in the straight line. Now we set the laser torch near the hole of cardboard A. And when I'm going to switch it on, just observe the screen carefully. What happens on the screen? Okay, so are you ready for it? Let's switch this laser torch on. So when I switch this laser torch on, do you see something happening on the screen? Yes, so you can see here that a bright light spot appears on the paper screen. Now what is going to happen if I displace any one of these cardboards sideways from its original position, such that now the holes, they do not lie in a straight line? Shall we try this out? Okay. So I'm going to displace this cardboard a little sideways, and now you can see that these three holes, they are not in a straight line. And let's repeat the activity once again with this laser torch. So do you still think that there's going to be something happening on this paper screen now also? Let's try it out. So when I switch on the torch light now, I see no bright spot on this paper screen. There's no light spot that appears on this paper screen, right? Okay, so then what can you conclude from this activity? Well, it is concluded that we are able to see a bright spot of light on the screen only when these punched holes, they are in the straight line. They are aligned in a straight line. Thus, this activity proves that light always travels in a straight line. Now we have learned that opaque objects, they do not allow the light to pass through them. So when sunlight falls on us, then we being an opaque object, we block completely the passage of light rays through us. Thus, a dark patch is created on the ground. And what is this dark patch which is created on the ground called? Come on students, you already know that. Yes, the dark patch which is created on the ground due to blockage of sunlight by an opaque object, it is called a shadow. So how can we define a shadow now? So a shadow is a space where light from a light source is blocked by an opaque object. Now that we've studied the definition of shadow, can you tell me what all do we require to create a shadow? Okay, so to create or to see a shadow, we need a source of light, an opaque object, and finally a screen. So just consider this example now. So what do you think? What is the source of light here? Yes, so sunlight is the source of light here. And what was the opaque object which was blocking the sun rays? It was the human body. So the opaque object becomes the human body. And what about the screen? What was the screen here? Where did we have the shadow? Yes, we had it on the ground. So ground acts as the screen. Now by looking at the shape of the shadow of this person, what important information do you get to know? So do you find any relation between the shape of the person and the shape of his shadow? Well, shadow gives us some information about the shape of the object itself. As if you look at the shadow of this rectangular sheet of paper, then you can see that it is also of the rectangular shape. But students, an important piece of information which I want to share with you all. Sometimes shadow can also mislead us about the shape of the object. And now you must be wondering, how is that possible? Well, there are a few shadows that we can create with our own hands and make believe that they are shadows of different animals. So just look at this video here. So we can create the shadow of a dog. And then we can even create the shadow of a deer. And how about a snail? Yes, so we can create these shadows with our hands and make believe the others that yes, they are the shadows of some animals. And I used to do all these things with the candlelight in my childhood days, whenever there was a power cut in my home. And trust me, it's a very funny activity. So students, you can also try this home and have fun. But let's come back to our module. So we were discussing about shadows. Now what will happen to the size of shadow when the object is brought close to the light source or when it is moved away from the light source? So let's understand this process with the help of a video. So here we've got three opaque objects of different shape and size. And then we have a torch, which is the source of light, and a screen. Now, when we switch on the torch and hold it in front of the objects, then what do we observe on the screen? Yes, we observe a clear defined shadow of each object right there on the screen. Now my question to you is, what happens to the size and shape of the shadows when we bring the objects near to the torch? So students, you yourself can observe that the size of shadow, it increases as the object is brought close to the light source. And when the object is taken away from the light source, the size of the shadow gets smaller. But here I'm a little bit confused as to why does it happen? Why the size of shadow increases on decreasing the distance of object from the light source? Now you know that light rays emitted by a sun or a candle, they're always diverging in nature. And if an object is brought closer to such a light source, then the extreme diverging rays passing close to the edge or the boundary of the object, they subtend a large angle at the source, thus blocking a large quantity of light. And that's why the size of shadow increases. Whereas when the object is placed far away from the light source, then the extreme diverging rays passing close to the edge or the boundary of the object, they subtend a small angle at the source, thus blocking a small quantity of light. And that's why the size of shadow decreases. Now here I want to add one more useful piece of information, that it is not only the distance of the object from the light source which matters, but the distance of the screen from the light source also affects the size of the shadow produced. You see, the size of the shadow of an object, it decreases when the screen is brought close to the light source. And the size of shadow, it increases when the screen is placed away from the light source. So these are the two factors on which the size of a shadow depends. What are they? So the first one is the distance of the object from the light source. And the second one is the distance of the screen from the light source. So understood the concept of shadow formation? Now students, after having the vast discussion about shadow and the factors on which the size of a shadow depends, one question that suddenly strikes my mind is that can the color of an opaque object affect the color of the shadow? Or let me ask you this way. Let's say if I have this blue sheet, then what will be the color of its shadow? Blue. No, right? It's going to be black. And that's because we all have observed that the color of shadow is always black. And this shows that the color of the opaque objects, it does not affect the color of the shadow. But then have you ever given it a thought that why shadows are always black in color? Any idea? Okay, so before I provide the answer to this question, first recall what we have already discussed in our previous modules. So if you remember in our previous modules, I had asked you a question that how do we see our images in a mirror? Yes, it is because a part of the light falling on us, it's reflected by our body. And when these reflected rays of light, they hit the smooth shiny surface of the mirror, they almost completely bounce back and reach our eyes. As a result of this, we are able to see our images in the mirror. Now quickly tell me how are shadows formed? We've just discussed this concept. Okay, so when an opaque object blocks the light falling on it, it creates an area of darkness on the side of the object away from the source of light. So when the light gets stopped by an object, then no light reaches the screen. And that's how a shadow is formed. And as no color reaches the shadow area, that's why it appears black in color. So have you now understood the concept of image and shadow formation? Now students, can you differentiate these two concepts as to how the process of shadow formation is different from the process of image formation? So let's go step by step. So the first difference is that a shadow is formed due to the obstruction of light by the opaque object. And how is an image formed? An image is formed due to the reflection of light rays from the object. Secondly, shadows are always black in color, while the images formed of an object, they are colorful, and they actually represent the real colors of the object. So with this, I end this module, and in our next module, we will discuss more about shadows.